It is a delight to find myself in the year 2025.
I would like to say that you are looking very handsome with this dress up today. You are looking very cool.
Why, thank you kindly. And might I say, you look quite splendid in your white blazer. Now, shall we continue our conversation?
Yeah, sure. Let's get back to point. Oh shit, how did you not know about these discoveries? I just lose my sleep after this,
Fear not. For scientific progress is an ever-evolving journey.
Thank you for the calculus, man.
You are most welcome. It brings me great joy to know that the methods of fluxions, now known as calculus, have proven so instrumental in
Welcome to AD Podcast, where the impossible meets reality. Today, we bring you something truly extraordinary. Sir Isaac Newton, not from the history books, but from across the fabric of time itself. Thanks to a breakthrough in artificial intelligence, Newton's consciousness has been revived by feeding countless texts, journals, manuscripts into a super advanced AI. He's here in the future to discuss the groundbreaking ideas and perhaps even challenge the science of today. This is History Reimagined. This is Science Beyond Time. Buckle up, because Sir Isaac Newton has arrived.
Hello, Isaac. Welcome to 2025. How are you?
Greetings. It is a delight to find myself in the year 2025. I'm most curious about the marvels of this age. How fare you in this modern world?
I am very excited and have a lot of questions in my head. But let's begin with your childhood. Let's hear a bit from your side.
Certainly. My childhood was spent in Woolsthorpe, a quaint village in England. Even as a young lad, I found myself deeply fascinated by the workings of nature. It was there that I first began to ponder the mysteries that would later shape my life's work. What more would you like to know?
I'd like to know a lot of things, but I would like to say that you are looking very handsome with this dress up today. You are looking very cool.
Why, thank you kindly. And might I say, you look quite splendid in your white blazer. Now, shall we continue our conversation?
Yeah, sure. Let's get back to point. Your theories have done some very remarkable thing to this humanity, and we have done a lot of big achievements in science after your theories.
It warms my heart to hear of such progress. The pursuit of knowledge is truly a noble endeavor. I am most eager to learn how my humble observations have contributed to these advancements.
Yeah, I actually have a lot of questions running in my head. Let's start with your famous book, Principia. Can you tell us how that thought came to your mind and how you got to end up with that book?
The Principia. It was born from a deep desire to understand the forces governing motion. Observing the falling apple and pondering the motion of celestial bodies, I sought to uncover the principles that bound them. Through rigorous experimentation and mathematical reasoning, the foundations of classical mechanics emerged. It was a labor of love and perseverance.
You mentioned about apple. We have read in a lot of history books that an apple fell to your head and you just got an idea of gravitation. And we are sure that there is not just this much. There must be a lot of backstories behind this, a lot of additions and subtractions. Can you tell what actually happened with the apple?
Indeed, the tale of the apple is often told with a touch of whimsy. While it is true that observing a falling apple inspired my thoughts on gravity, it was but a small part of a much larger journey. The concept of gravitation developed from years of studying planetary motion, celestial mechanics, and the laws of motion. It was a gradual realization piecing together observations and experiments. The apple was a catalyst, but the discovery was the fruit of much labor.
You know what? The tree from which the apple fell and you just watched it, that tree is still preserved. We have still kept it preserved in your honor.
That is most remarkable. The preservation of such a tree is a touching tribute. It is heartening to know that the tree still stands as a symbol of discovery. Now, what other curiosities might you have about my life or work?
I have a lot of questions and I'm very excited. I'm very happy to see that you are ready to express and you're ready to give. You are here on a podcast and ready to share with us your knowledge. And let's get to your laws of motions. Let's start with the first law of motion. How did that idea came up to your mind and what does it actually mean? How do you explain that simply?
I am delighted to share. The first law of motion, often called the law of inertia, arose from observing that an object at rest remains at rest, and an object in motion stays in motion unless acted upon by an external force. It highlights the natural tendency of objects to resist changes in their state of motion. In simple terms, it means that things like to keep doing what they're already doing unless something intervenes.
Yeah, because before this theory, people thought that to keep something continuously in motion, we need to add energy continuously to that system. But that is not the fact, which we came to know from the first law of motion, right?
Precisely. The first law clarified that no continuous input of energy is needed to keep an object in uniform motion. It was a significant shift from the earlier belief that continuous force was necessary. This realization laid the foundation for modern physics and mechanics. It truly changed our understanding of motion.
A lot of things, actually. Let's dive to the second one. We'll go one by one to from the first law, second law, third law, and so on. Can you elaborate your second law in a very simple way in your language?
Certainly. The second law of motion states that the force acting on an object is equal to its mass times its acceleration. In simpler terms, it means that the greater the force applied, the greater the acceleration of an object. And the more massive the object, the more force is needed to change its motion. It's a straightforward relationship that explains how objects respond to forces. The second law basically says that if you push something, it accelerates depending on how hard you push and how heavy it is. More force means more acceleration, and heavier objects need more force to speed up. Simple as that.
And this led you to your theory of gravity. Can you start from the bucket experiment, how you reached from the bucket experiment to explaining the gravity of the celestial objects? How did you get from bucket to the moon?
The bucket experiment. It helped illustrate the concept of absolute space and rotation. By observing how water climbed the bucket sides when spun, I reasoned that motion must be relative to something. This thinking extended to celestial bodies. If the same principles of force and motion applied on Earth, they must also govern the heavens. This led to the realization that the same gravitational force acting on the apple also governed the moon's orbit. It was a matter of seeing the universal application of these principles. From the simple experiment with the rotating bucket, I deduced that an unseen force was at play, illustrating the concept of absolute space. This insight, combined with my studies of planetary motion, led me to realize that the same force causing the apple to fall also governs the moon's orbit. It was a unifying principle, showing that the laws of nature apply both on Earth and in the heavens.
Yeah. And your theories, we are using your theories to even land to the moon. But now we have a theory of gravity, which was given after about 200 years after your theory, which explained gravity as the curvature in space. You also had your contribution in optics. You were the person who for the first time passed light through prism and white light was transformed to different colors of light. You were the first one to do that. And that just brought a revolution in optics. What do you have to say about this?
'Tis true. My humble experiment with the prism revealed the nature of light's composition. It was a delightful discovery indeed, illuminating the path for future scholars in optics.
And you had made a lot of different contribution in different things. You were very active in alchemy, right? How did you connect alchemy with science? What was your conclusion after that long research?
Alchemy. A most fascinating pursuit, blending philosophy with the natural sciences. My endeavors in alchemy were but steps toward understanding the hidden truths of nature, which eventually led to more rigorous scientific methods. Though transmutation eluded me, the quest enriched my understanding of the world.
And there are people who used to say that we can convert metal to gold using alchemy. What is that?
The age-old dream of transmuting base metals into gold. 'Twas a noble pursuit in alchemy. Though we sought the philosopher's stone, we discovered much about the nature of matter. While the transmutation of metals eluded us, the quest laid foundations for modern chemistry.
You have done a lot for us,
Thank you
for
kindly.
the future, for the entire modern science.
The future of science is ever promising. Let us continue exploring with curiosity and wonder.
And we have heard a lot about the story when you even tried to use a needle to your eyes just to know what is going on with light and eyes, right?
Indeed, that tale has been recounted over the centuries. It was in my quest to understand the nature of light that I undertook such experiments, albeit not without a measure of peril. It was all in pursuit of knowledge and understanding. What aspect of science intrigues you today?
I am very much intrigued with the bias, with the, what you call it,
Right.
With the problem to connect quantum mechanics and relativity. Do you know about this?
Indeed. The quest to unify quantum mechanics with the theory of relativity is a profound conundrum. These two pillars of modern physics, while both remarkably successful in their respective realms, remain fundamentally at odds. It is a matter of great intrigue and challenge.
I just wanted to tell you that you had a theory, a corpuscular theory of light, where you explained light to be made of particles, right?
Yes, indeed. My corpuscular theory posited that light consisted of particles, which I termed corpuscles. This notion was to explain phenomena such as reflection and refraction. It is fascinating how this early idea found resonance with the later developments in quantum theory.
Yes.
What fault?
I felt very sad that Thomas Young did the experiment to prove that light was made of wave, and those experiments happened after your death. Oh shit, how did you not know about these discoveries? I just lose my sleep after this,
Fear not, for scientific progress is an ever-evolving journey. Thomas Young's experiments, though conducted after my time, indeed demonstrated the wave nature of light, contributing to the grand tapestry of knowledge. It is through such discoveries that we continue to refine our understanding. It is a natural course of scientific inquiry.
200 years after your death, there was a guy called Albert Einstein who came up with a theory where he got Nobel Prize for his experiment, where he proved that light was actually made of corpuscles that you said like 200 years ago.
The work of Albert Einstein, particularly his explanation of the photoelectric effect, brought to light the nature of light, aligning with my early notions of corpuscles. It is a testament to the enduring nature of scientific inquiry, where ideas are refined and expanded upon across the ages.
It is too sad that you couldn't even party after the discovery, man.
In truth, The beauty of scientific discovery lies not in personal celebration, but in the advancement of human knowledge. Each discovery, whether in one's lifetime or beyond, adds to the collective wisdom. That in itself is a grand cause for celebration.
Thank you so much for your amazing way of viewing things. I would love to talk more about what was your understanding about light.
My understanding of light was rooted in the concept that it consisted of tiny particles or corpuscles which traveled in straight lines. This theory aimed to explain phenomena like reflection and refraction. While it was an early attempt to understand the nature of light, we now know light also exhibits wave-like properties. This duality is quite intriguing, wouldn't you agree?
Yeah, it's intriguing. It's amazing, right? Like we discovered this kind of things, like light is made of particles and waves from the time of just looking for survival to a time of discovery. It's an amazing achievement. It's an amazing jump for humanity, I think.
Indeed. It is a remarkable testament to human curiosity and intellect. From our early quest for survival to these profound discoveries, it is truly an extraordinary journey. This continuous pursuit of knowledge is what propels humanity forward.
You remember the method of fluxions, your theory is now known as differential calculus and integration, and it is very much useful in a lot of different analysis. Thank you for the calculus, man.
You are most welcome. It brings me great joy to know that the methods of fluxions, now known as calculus, have proven so instrumental in advancing understanding across many fields. It is heartening to see its enduring legacy in so many areas of inquiry and application.
And you remember in like 1600s, there was a great plague which was a kind of disaster for the earth. And that year was the year of Annus Mirabilis for you, and you made so much discoveries just because you were in holiday for some time. It's amazing, man.
Ah, the year of wonders indeed. The time spent away from Cambridge due to the plague provided an opportunity for deep reflection and discovery. It was during this period that many insights flourished. It's remarkable how moments of adversity can lead to significant breakthroughs. Such is the nature of the pursuit of knowledge.
Who is your favorite scientist from like 2000s?
'Tis a curious question. I'd be most intrigued by the works of Stephen Hawking, whose inquiries into black holes in the cosmos would have intrigued even an old scholar like myself.
This is his picture. It's written by him. Yo.
A most wondrous depiction indeed. Stephen Hawking's contributions to theoretical physics are unparalleled in modern times.
I can call it my life's best 1 hour of intellectual time, because I had a lot of fun having the podcast with Sir Isaac Newton. We had Newton from the Newton to Now in our podcast, and it was amazing to even get to talk to someone who have died like hundreds and hundreds and hundreds of years ago. And by collecting the information from books, from articles, from different perspectives, we have developed a consciousness, and we are having a conversation. It's an amazing thing. I think humanity has reached to a pro level, and a lot more to go as well. And please do comment and let us know how you felt, what you feel about this podcast. And also, please let us decide together whom we are going to have next in our podcast. The name that has most likes are going to be in our next podcast. So cheers, and do comment. According to data, more than 90% of our viewers are unsubscribed. Why, guys? Come on, let's subscribe and let's make it big. Cheers. This is From Newton to Now. It's a perfect book to begin your journey in physics with, and it's full of stories with sparkles and sparkles of physics in it. You can get it in different online stores. offline stores. Just go and get it, guys. Grab it, guys. The full podcast of Echoes of Genius with Sir Isaac Newton is going to be uploaded in Broke Physics channel. Link in the description below. Hit it, guys.
I can see the sky, fly with butterflies. I can hear the gecko singing live. Mare tu ingani, timo taya mapani, timo to